we're going to try this again. This right here is the atomic number. Okay? The atomic number is the same thing as protons. They're the exact same thing. Atomic number and protons are the exact same thing. So you see this number right up here, 2. Second element has 2 protons, helium. The atomic mass is the bottom number. The atomic number is protons plus neutrons. That's it. To get the atomic mass, it's the same thing. The atomic number is the positives, the protons. This is the symbol. It's helium. That you don't need to know. This one is the atomic mass. To get the atomic mass, you take everything that's in the nucleus. What is stored in the nucleus? Protons and neutrons. So right here, this is your nucleus of the element, protons and neutrons. On the outside of it would be electrons. So electrons, if there's no charge, protons are positive, electrons are negative. If the element is balanced, it does not have overall charge. That means the positives has to equal the negatives. In the periodic table, everything is balanced. So any element that you look at in the periodic table is the same number of protons as electrons. So charge equals, charge equals, protons plus electrons. They're equal. So if there's no charge, then you're going to have the exact same number of protons as you do electrons. All right. Okay. What's the isotope, Lisa? An isotope is the same number of protons, so it's the same element, but it has different number of neutrons. I knew you were going to get that at some point. All right. An ion. What's an ion? Reagan? Maybe if you look it up fast enough, you'll get that too. That's has a different number of electrons, so it's got a charge. So let's just pick an element. Let's say chlorine. Here. All right, so the element chlorine, its atomic number is 17. According to the periodic table, it is 35.4, so that would be 35. All right, so this is what it looks like. So what would 17 represent? Yes, it's the atomic number. But what does that tell us right away? That we have 17 protons. We have 17 protons. And from there we can work our way. This gives us all the information to let us know how many protons, neutrons, and electrons there are. So protons is the atomic number. Boom, we've got 17. We know that the atomic mass is protons plus neutrons. So if the atomic mass is 35 and we have 17 of them are made of protons, then neutrons has to equal 18. And there's no charge written. There's no positive or negatives written over here. So what do we know? We know that there's no overall charge, so we have the same number of protons as we do neutrons. I'm sorry, I said it. Rewind that. We have the same number of protons as we do as electrons. Those are the only two with charges. Protons are positive, electrons are negative. If there's no charge, then you have to have the same number of positives and negatives. Same number of protons as electrons. Okay, so here's some more that I've just written out. We have lithium. It's element number 3. Howard, how many protons do we have? Correct. 3. I knew you'd get that correct. You're all that. You're the bomb.com. Sorry, Faithlin. All right. So from each one of these squares, we could get protons, neutrons, and electrons. We got the protons. This is atomic mass. What is atomic mass? Oh my gosh. That was Gay Julie coughing up a lung. He's got to quit that smoking. All right. So 3 protons. We know that protons plus neutrons equals electrons. So protons, which is right here, plus neutrons, which we don't have, equals this, right? We have said that many WAPO amount of times. All right, so 3 plus what equals 7? 4. That's right. So neutrons equals 4. Again, there's no power sign over here that says that there's an overall charge, so that means that it's neutral. So we know that the electrons are the same as the protons. The charges are the same. You have 3 positives, you have to have 3 negatives. Okay, back. All right, highlighter. Okay, now these next ones have overall charges. These next 4, you can see these charges. Outside the box, we have put a positive or negative. Okay, so now all that's going to change is electrons. It doesn't change anything else. So we still know that the atomic number represents what? That's right, Megan. The number of protons. So the number of protons equals the atomic number, 20. Boom. Calcium's got 20 protons. Okay, so now we need to know neutrons. We know this, which is protons, plus neutrons equals this, which is the atomic mass. This plus something equals 42. Well, that something is going to be neutrons. So how many neutrons does this element have? 22. All right, now electrons. Okay, so let's just put neutrons, protons. Now electrons. Electrons is going to equal this, so we have 20. However, we have an overall 2 positive charge. To get more positives than negatives, we have to take away 2 electrons. We can't take away any of the protons because that would change element 20, calcium, to argon. So we can't take the protons away. We can only take or add electrons. So we have 2 more positives than we do negatives. We start with 20, so we have to have 18, right? 18 of negatives, or 18 electrons. Now you're rolling. Now you got this. All right. Let me think. Who's in this class? Damien. Damien and Tyra. That would be good. Damien and Tyra. These are yours. How many protons? You know, protons and atomic mass are the same. Correct. Protons equals 16. All right, you know this plus neutrons equals this. So you know protons plus neutrons equals atomic mass. This is the atomic mass. This is protons. So we know neutrons equals what? What, Damien? Yes, 14. Talk louder. I can't understand you. All right, Tyra, this is your moment in the sun. We have electrons. We know that if it's a balanced charge, that the protons and electrons are the same. They equal the same. So right now we have 16 electrons. However, this element has an overall negative charge. That means it has to have one more electron than it does protons. We've said that it's got 16 protons, so that means it's got, good girl, 17 electrons. Nice job. All right. All right, Maya, if you could talk with that hole in your nose, this is going to be your turn. So we have protons. Again, should have this down now. Where are protons? It's the atomic number. That's right. 7. Now we can get neutrons from what's right here. Protons plus neutrons equals atomic mass. Well, the atomic mass is right here. We know that protons is 7. So what plus 7 equals 16? 9. Good job. Now the only semi-difficult one you have is you have electrons. But again, you know that you start off with the same amount of electrons as protons. So you start out with 7. However, you have one more positive charge, so you do negative charges. You can't take away a proton, or you can't add a proton, because that would change it to oxygen. So since you can't add a proton, you have to take away an electron. So instead of 7, you're now down to 6 electrons. Got it? I think you're getting it. Protons. All right, Austin. Romine, I think you can handle this. After 42 times, you've got this. All right, how many protons? Atomic number, 5. Good job. All right, so protons plus neutrons equals atomic mass. Does this sound familiar? I hope. So protons is 5. What plus 5 equals the atomic mass? So it's 13. 8. Do you know why? You know why 6 is afraid of, wait, what is it? Do you know why 7's afraid of 8? 7, 8, 9. No, wait. I don't know if I did that right. All right, but you have a overall 3 negative charge. 3. You're going to have to add up more 3. So normally you have 5 electrons because it is balanced. But you have 3 more negatives than you do positives. So that would be 3 plus 5 is 8. All right. So all this. Number of protons. Protons plus neutrons equal this. And electrons, if there's no charge, is the same as protons. Okay? I hope so.